Okay, let's start. So, hi everyone. I am Mayank. I lead the Retrieval and Search sub program for Cohere Labs. So, we are gathered together for one of our sessions in Retrieval and Search sub program by Ihor Stepanov around uh, zero shot name entity recognition with GLineR and its recent advancements. Me and Ihor have been doing some communication and transactions around GLineR and few other zero shot retrieval frameworks for past 1 year, and uh, I think it would be a great session for newcomers and upcoming PhD students as well. So yeah, let's start the session. The recording has already commenced, and you're over to you. You can share your screen and we can start.
Yeah, sure. So first of all, thank you everyone for joining the session. And today I will talk about zero-shot name-entity recognition with GLiNeR.
I think you're not audible.
Sorry?
Okay, you're audible.
Yeah, so today we'll talk about zero-shot name-entity recognition with GLiNeR and recent advancements. Yeah, and my name is Ihor. I'm co-founder of Neogy, the startup from Ukraine. We are focusing on information extraction solutions. And agenda for today meetings is, first of all, understand what is NER is itself, what is basically why we need zero-shot abilities for modern models, and what is the history of these approaches. And then we will switch to GLiNeR, we will talk about its original architecture and all variations our team developed. Then we will discuss advantages, disadvantages of these approaches compared to LLMs and other methods. And we will discuss future directions for improvements and summarize all the recent advancements. So first of all, what is NER itself? It's name-entity recognition. It is a subtask of information extraction where we locate and classify named entities. It can be used for various purposes, for example, organizing structured text, improving search and retrieval, building knowledge graphs, and detecting personal information. So it's especially easy to apply if your text is in some sense already semi-structured. So for example, it's focused on a single entity, this text describes some company, and you can extract and link entities and construct some tables from it. Another possible use case is basically constructing knowledge graphs. This is especially popular right now with arrays of graph RAG systems, which significantly can improve LLM-based systems by adding more context. And NER is one of the key initial steps for that. And of course, for improving search in real time, because a user can drop some unambiguous search request, and we need to understand that it's a company, not like rainforest. And of course, this one, by the way, this is one of the most popular use cases right now for GLiNeR, which is personal identity information in reduction. So this is when we find personal health data, financial data, and we basically hide it for both for legal purposes, but also for technical purposes. And of course, we have quite a lot of meeting assistance, meeting notes assistance right now. So we can apply NER type of models to find personal information in this kind of data. And we can move forward to discussing basically what approaches were developed for this task. But let me first describe what is zero shot. So basically, zero shot means that we can identify entities and classify them, even if our model didn't directly see it during training. So, of course, we rely in this case on internal knowledge of backbone models used, like in the case of GLiNeR, it's encoder models. In the case of LLMs, this is decoders. Yeah, and in the past, there were developed different approaches for that. Like one of them, like based on encoders, like GLiNeR, which represents text and labels in the same context. Another approach and line of research is of the LLMs, where we can just instruct them and construct some prompts to extract entities. Like before LLMs, popular approaches for like representing any task as some sort of question answering, when we like basically request an encoder like extract certain types of entities. And in this way, obviously, we need to construct as many, like basically forward passes through the model as we have labels. So it's less efficient than GLiNeR. And like pretty similar approaches, like natural language inference approaches. This is when we compare two sequences, whether they align or not. It can be used for zero-shot NR, like we did it with our comprehended model, but they are super inefficient because you need to construct, like you need to pass through the model like such like n times, and n is basically amount of entities multiplied by amount of labels. But such approaches can be good if you haven't enough. Like if you have just few labels and you need really good precision. And of course, there are some more like specialized sequenced models based on encoder decoder architecture that are trained directly for NR. And each of these approaches like has its own advantages and disadvantages. We will talk about it more in more details later. But let's like move to the GLiNeR itself. So what it makes it more efficient and accurate at the same time. So first of all, because we represent our labels, so basically this entity types and text in the same context. So this means that representation of, for example, organizational label will receive information from both other labels presented in the prompt and text itself. So we can deal with more like nuanced cases where like meaning of a label can be derived from a label set itself. Like, and in the original GLiNeR architecture, we represent, as I said, entities and text using the same encoder in the same context. Then we derive entity embeddings, and we derive span embeddings using span representation layer. And after that, we compare representations of both labels and spans and find alignment between them. And in the original work developed by my friend Rakesh, GLiNeR achieved superior performance to existing at that time LLMs, like more general domain, like it was GPT 3.5 at that time, and Uni-NR. So basically, this is 7B parameter models, directly, like decoder model, directly trained to perform NR, and GLiNeR achieved better performance and as well as better throughput because GLiNeR model is much smaller. And more recent research also show us that GLiNeR demonstrate both better efficiency and performance in comparison to more modern LLMs. Like right now, it's called more. You can call them more small language models like Llama 8 billion parameter, etc. And at the same time, you can see that GLiNeR achieves better performance on both general domain and more specialized, like medical domains and legal cases. Yeah, we discussed a bit GLiNeR architecture itself, but from practical standpoint, it's really easy to use GLiNeR. You can import it using GLiNeR package, and there is just predict entities method to call it. If you need to run it through the large batches, use run method. So you can find everything in the GLiNeR README file. Let's also dive deeper into details. So, of course, like architecture itself, meaning interaction between parts of architecture, means a lot. But also, we observe that backbone choice is super important, and Liberta is by far the best model for that. So we compared Liberta to both like relative positional encoding models like T5 and to modern models based on rope, which is a relative positional encoding approach. Yeah, and Liberta is by far the best. So we can maybe articulate why it's true. So my hypothesis is that because of architecture of Liberta itself, so it represents like basically tokens, like say content information, position information in different vectors, and like interaction between tokens are defined by both like they, let's say, semantic meaning, but also how like what is the relative position between them. So in this way, the model can learn that, for example, some tokens, some specific set of tokens, like after some distance, can have like better convergence or vice versa. And this is really important for GLiNeR because we need to aggregate information into label tokens, and Liberta is doing it really efficiently. So, but Liberta is not well optimized on modern GPU because of its unique attention mechanism. So we developed our custom writing kernel for that, and you can see that it achieved much better inference speed in comparison to just naive PyTorch implementation. And this is true especially for longer sequences because like memory bottleneck becomes to be more like more important at larger sequences. But original GLiNeR architecture is limited to the ability to a model to process context. So imagine if you have like thousands of labels, your context will grow significantly, and performance can drop as well. So typically, a union encoder GLiNeR works well up to 50 entity types. So we decided to develop bi-encoder architectures that separately encode text and spans, text and labels. And so we train such models using contrastive objectives, and we can pre-embed our labels to save some inference time. So typically bi-encoder models are much faster for large label sets, like hundreds or thousands of labels. So as you can see, we use basically for encoding entities, we use typically some sentence transformers like BG, etc. And again, for encoding text, we use Liberta or other models. Important also to add that in this case, Liberta becomes less, like Liberta attention mechanism becomes less important, and Also, role-based like encoders like ModulBERT demonstrate a good performance. But of course, you need much more data to a good, wonderful performance for these models in comparison to union coders. So we trained it on 1 million examples derived from FineWeb. And more recently, we scaled it to 10 millions. But still, this result is not published yet. Yeah, and at the end, we get a more scalable model, which is able to represent entities well. So we basically projected representations from labels into this space, and we see that the model is able to group entities into meaningful clusters, which is not a case for basically typical untrained sentence transformers, because they were trained on different data. And this is not the last GLiNeR derivative. So we also developed GLiNeR decoder, because in many cases we don't know basically labels and entity types we need to extract. So in some cases we need to open ontology and image recognition, and for that obviously we need some decoding mechanism. And here's how architecture is looking right now. So again, we represent spans using some bidirectional transformer, and we then concatenate these spans with basically embeddings from decoder, like the first decoder layer, and we run it through the decoder itself. So this is how training is represented. So this span embeddings, and this is basically token embeddings for entities. We pass it through the decoder transformer, and we train it in basically autoregressive manner. And for this type of GLiNeR models, we use both two losses, focal losses in original GLiNeR, basically to train model select two positives, and basically cross entropy loss to train decoder, basically to generate labels for our entities. Let's summarize advantages and disadvantages of each architecture. So union coder is good at cases where we need deep context understanding, especially if label set can influence it. The disadvantages is that it can work only on moderate or small label sets, like up to 50 entity types, and it can require some additional calibration of threshold. This is also true for bioencoder, but advantage of bioencoder is that it can scale to thousands and even millions of entity types, which opens new use cases like entity linking. And on encoder decoder is good for open information extraction when you don't know which entity types you will encounter and you need to extract. Is good also for GraphRag applications. And another important direction of research is multitask models, because GLiNeR architecture is more general, and we can consider many tasks as span extraction type of problems. So for that, like in the previous year, we developed GLiNeR multitask model, which can perform question answering, summarization, classification, key phrases extraction, etc. And it uses a bit different architecture. So original GLiNeR is using span-based architecture, and our friend Richard developed token level basically GLiNeR, which we applied to our multitask model. And the main benefit of this is that we can extract basically unlimited by lens sequences from text. Yeah, and in the case of original GLiNeR architecture, we are limited to, for example, to 12 tokens or words that can be presented in a span. So this is how more formally we represent this new architecture. So we train our model basically to define, is this word beginning or it's inside or the end of an entity. And during decoding, our scores basically will be an average of inside token scores. And once again, the main benefit of it is that we can extract long sequences, which is especially beneficial for summarization. So we developed a simple gradual demo that demonstrates the ability of this model. So, for example, this is how it works for question answering. So we can define some question here, and it will extract answers. We can also define some more complex prompts, like extract all positive aspects of certain product, and it's doing it well. And as you mentioned, another exciting application is summarization. And once again, it's possible because of token level architecture of GLiNeR. So yeah, and in comparison, like to just generation-based approaches, we can control like how many text segments we want to put into our summary. We can control it with threshold. And also another very important application is relation extraction. And relation extraction currently is widely used for constructing knowledge graphs, again for graph rack. And we can how we can use GLiNeR for that. So currently there are more specialized GLiNeR architectures for that, like GLiRL, but we can basically represent our input entity, like labels, as source entity and relation. So in this way, we need to extract entities first, and then we generate all possible pairs between entities and our relations. Like in this case, relation is worked at. And so basically, our GLiNeR will extract Dr. Paul Hammond as a target entity. As a source entity, and as a target entity, it will be Johns Hopkins University. So let's summarize in general what is the advantages of GLiNeR in comparison to LLMs. So first of all, it's low latency. It's very important if you need to basically process millions, even billions of documents, or you need to run your models on edge devices, which can be important for privacy reasons. And again, GLiNeR can be used for personal information identification. And another benefit of GLiNeR is that outputs are deterministic. You always know that a model will return outputs in the same format, and you can control precision and recall using threshold, which is very hard to do with LLMs. But at the same time, LLMs are good because you can define your more complex prompts and instructions for your task, especially if it has a lot of nuances and rules. Plus, usual LLMs have like larger external internal knowledge. But again, with our new GLiNeR encoder-decoder architecture, we can combine benefits of both worlds. Still, in many cases, we can combine GLiNeR and LLMs in the way when GLiNeR first extract all possible entities, and then we, in some sort, like basically sort them or filter them using LLMs. Yeah, and what about the future search directions? So we're super excited about multimodality, especially in the case of PDFs. So in this way, it's important to encode 2D layout information because it can influence the meaning of certain entities. And obviously, in certain type of, especially like using GLiNeR multitask, multimodality can enable a lot of use cases with documents and in the cases when like visual information of a document can influence extraction results. Yeah, and another important direction is basically multitasking, adding more tasks, adding ability to process several tasks in the same, like during the same forward pass. It can store, it can make like the system much more efficient if we can, for example, classify our text, extract all entities, construct JSON in a single forward pass. And as I mentioned, backbones for GLiNeR is really important. As you saw, like modern encoder architecture is suboptimal for union encoder GLiNeR. So we see a lot of potential in new encoder architectures to improve GLiNeR performance. And yeah, as a conclusion, I can say that GLiNeR is a super efficient alternative for zero-shot NER. And it can be used not just for name-image recognition, but also multitask variant for summarization, text classification, and many more tasks. And we can combine GLiNeR with LLMs in pipelines. And we see a lot of potential in multimodality and better encoders for GLiNeR. So that's it. Thank you everyone for your attention, and your questions are super welcome.
Okay, I think we are open for Q&A now. Either you can post your questions in the chat and I can read it out, or you can raise your hand and then open your mic and ask on your own. I think there are a couple of questions from Prajwal in the chat. One is, can GLiNeR be used for fast structured data extraction based on pydantic schemas, similar to instructor library plus LLMs?
Yeah, sure. Yeah, as I said, this is one of the future directions of research, and I know that several groups already are working on it. So the answer is yes, if you basically, in your case, content of JSON can be derived directly from the text, meaning that if you need some like regeneration or summary or certain fields, it's better to use like LLMs, but in any way, if you can construct a JSON just from text itself, so yes, it's possible, but still this is like an active research direction for now.
Okay. I think there is a follow-up question over there as well. If so, is there a way to get results with accuracy on par with LLMs such as GPT 4.1 or Claude IQ? And would model fine-tuning help here?
Yeah, for sure. So in several research, we see that GLiNeR performs even better than LLMs, like in dozen of times larger than GLiNeR itself. And it depends, of course, it depends on the domain. In some like more simple use cases, GLiNeR is obviously is faster and sometimes even more accurate than even super large LLMs. And of course, like another benefit of GLiNeR is that you can fine-tune it on your like specific task, and it obviously increase performance. Still, LLMs are a good choice when you're dealing in very like complex scenarios, which requires a lot of external knowledge, and or you have like very like a lot of rules on how you need to extract your specific information.
Okay. Any more questions from anyone? Or I do have a couple of questions on my own. Okay. I think Tom says that he's a big fan of these models. So, okay.
Yeah.
I do have a couple of questions. So one is, have you tried like mining maybe hard negatives over here? Like negatives like where spans are overlapping across entities? And any numbers which reflects how do these help?
Yeah, so for sure, like hard negative mining can help. GLiNeR is can be applied for cases when you have like your entity can consist, let's say, from several entities. Um, so it's possible because we generate spans with different lengths, and of course they can be overlapping. But in many cases, here the task is is not even correctly identify like entity label. Usually, GLiNeR is working well even from scratch with overlapping entities. Usually, the hardest task is when you're working basically in very hard domains like biomedicine. And in this case, hard negatives is obviously helpful because sometimes there is a strict boundary like between, let's say, disease condition and like protein gene. And for GLiNeR model, it can be hard to distinguish. So in this case, hard negatives are really very important. And we can, like, at technical level, we basically implemented, like in the training, that we can manually or like automatically add hard negatives to our training examples. Yeah, and again, it can improve performance a lot. I don't have like any specific numbers right now, like near my hands, but yeah. So intuition is what I described.
Okay. There is one more question from Tom. He says that you have tried Modern Bird, and he knows that. Have you tried the Aten line, the Aten suite of models, which was like I think introduced recently in the past few months, which I think they are merging or they're like pairing the SOTA encoders and decoders. And he says that they use a wide variety of newer weights as well as range of sizes across parameters.
Yeah, it's a line of models is really amazing line of development in the field of encoders because yeah, it covers a lot of different sizes of models. We try to use these models for by-encoder architecture. So this kind of active work, but we didn't compare them in the same conditions as you can see in this slide. Still from our early experiments, team models demonstrate better performance if they're the same size as modern birds. For bi-encoder architecture, still more research and relations needed for union encoder architecture to see how it performs.
Okay. There is one more question from my end only. So since now we have an encoder decoder variant of GLiNeR, how easy will it be to convert maybe a zero shot setting to a few shot setting for maybe a more closed domain NER extraction tasks?
So as I understand by few shot setting, you mean basically in context learning.
Yes.
So let me back to basically GLiNeR decoder architecture. So basically how we train it is and how we construct basically our span sequences is the following. So we concatenate span representation derived from encoder with tokens from decoder. And it means that we can put information like some prompt in context examples we put into span representations or basically entity tokens. This is still to be done, so this interesting direction of research. But there are two ways. I would say that probably adding in context information to entities will be more performant because basically it will be closer to how decoders were trained originally, but it will be more demanding from basically computational standpoint because we will have longer sequences we need to from which we need to decode. So I would say that maybe in certain cases, for some simple prompts, it should be possible to put information to span representations, and in this way we will reduce computational demands as well, and will achieve good few shot results.
Okay. I think there is one more question from Prajwal. He asks that curious how GLiNeR models can be incorporated into LLM workflows like chatbot or deep research systems. So in my perspective, it's more of kind of a broad question, but if you could share some light.
Yes, sure. So first of all, GLiNeR can be easily applied with together with LLMs because, for example, we can use GLiNeR for reducing personal information and then feed all prompts and input data and user puts into LLMs. We can use GLiNeR to, again, if it's some sort of information extraction task, we can use the following pipeline when we initially extract all possible entities with GLiNeR, and then we put this entity syntax to LLM and ask it to refine outputs. So usually it's helpful, especially it's also helpful for LLMs because the drawback of LLMs is that in the case of NER, they can fail to extract all entities, so recall is not well. So with GLiNeR, we can control recall precision much easier with threshold. Probably there are many more use cases. I can imagine using GLiNeR for entity linking. it can be helpful, for example, if you need to understand that, for example, this entity is like concretely is a company, not like rainforest or not something else. So yeah, and you have a database of millions of entities. Obviously, it's hard to put millions of entities into LLM because its context will not allow to do it. So GLiNeR can be used much easier for retrieving information about specific entities. But as I mentioned, yeah, probably I should start from it. GLiNeR can be used for constructing knowledge graphs, which are used for LLM-based systems, like with GraphRag. And GraphRag is super helpful if your question requires combining information from several sources, and classical like embedding-based retrieval systems can fail with it. Yeah.
Okay. There is one more question from Anthony. He asked, have you explored solutions to make uni-encoder GLiNeR models invariant or more robust to the order and number of entity types at inference time?
So can you repeat again the question?
Yes. He asked, have you explored solutions to make the uni-encoder GLiNeR models invariant or more robust to the order and number of entity types at the inference time?
Yeah, that's a very good question. Yeah, so because you encode labels in the same like context using a single encoder, it has one drawback is that like positional information can influence representations of entities, and it can like it can increase amount of noise and stuff like that. So more positional invariant versions of encoders, or at least more flexible encoders that can better distinguish and utilize positional information with semantic information is definitely needed. So currently we deal with it by augmenting our data. So by training a model with different like label amount of labels, so and basically with a different order of the same label set and the same example. But yeah, I would say that probably more like better encoders can be more helpful and more universal for this aspect.
Okay. Any more questions from anyone? I think Tom has one more question. Generally, would gathering only one NER entity type per inference result stronger performance than gathering all desired entity types in one inference? Is that whether this is true or not?
Yeah. So for example, like more in this year, like IBM developed basically zero NER model, which represents entities and text, like all entity types separately in different forward passes. As they claim that they got better performance, and from our experience, we had similar experience with our GLiCLASS models, which is basically a derivative of GLiNeR that can do classification. And before GLiCLASS, we had cross-encoder models, which basically represent a single label and a text in one forward pass. So obviously you need like an amount of forward passes where n is amount of labels, and cross encoders performed better, but then we achieved even better results with GLiCLASS. And it was done through like better data augmentation, as I mentioned, basically like creating examples with different amount of labels. So in this way, our like encoder model learned better how to deal with positional encoding bias. So I would say that it's easier to train a more performant model using when we use like several forward passes. But it's possible, and I think overall a model like GLiNeR should be more performant if you train it in the right way. Plus, like representing all entities in a single context is beneficial when, again, you have entities that can have different meaning, and its meaning can be derived from like the whole context. And by context, I mean label set. Like, for example, you have organization and company labels. So it means that, if, for example, you want to find the more specific type of organizations like companies, not and like approach like GLiNeR, they can fail to do it properly because they don't get information from the whole label set.
Okay. I think Bronson has raised his hand. This will be our last question. So Bronson, you can unmute yourself and go ahead.
Yeah, so mine is not so much a question, but just some feedback. And I did have an interesting use case where I wanted to extract a few things out of text, and I just tested it out, and it's pretty impressive, I have to say. So, you know, just great to see something like this that could actually fit on a tiny device. So thank you so much.
Yes, thank you for your feedback.
Okay. I think these are all the questions from the community. Thank you, everyone. Thank you, Ihor, for like taking out time from your schedule. Okay. I think there was one question from Savik. Savik, you raised your hand. Okay. Then we'll wrap this up. Okay. Yeah, the recording will be shared on our YouTube channel, for the official YouTube channel for Cohere. Let me just paste it in the chat. So the recording will be available over here. Also, I think we'll share the recording link to in our Discord community as well for Cohere Labs. So it will be available there as well once the recording is live on YouTube. Okay. Thank you so much, Yor. Thank you for taking out time from your schedule. Thank you for doing some great work around GLiNeR. I personally will be following up around, especially the work around zero shot and few shot NER, because I work around retrieval and search a lot. So yeah, thank you so much. Have a good day, everyone. Bye bye.
Thank you, everyone. Bye.